Alright, so today we're going to work on Chapter 10, Sequences and Scales. A sequence is a number of numbers, I guess. A list of numbers, that would be a better way to describe it. A list of numbers that all have the same relation to each other. What does that mean? Alright, so if we start with 5 and go to 10, the next one is 15, and that pattern continues. 5, 10, 15, 20. So what is happening in between this first number in the sequence and the next number? We want to describe this pattern that's happening in between these two numbers. So 5, we know that this is increasing. So when we increase, we have two different signs that will result in an increased number. We can either add or multiply. Okay? 5 times, let's go with multiply first. That's not the right answer, but let's try to think multiply. 5 times what number equals 10? Well, 5 times 2 equals 10. But if I take the next number, 10, and I multiply that by 2, what's 10 times 2? Does that equal 15? No, it does not equal 15. So this little pattern, multiply by 2, does not work, because 5 times 2 is 10. 10 times 2 is not 15. 15 times 2 is not 20. So multiplying by 2 is not the correct pattern for this sequence. Okay, so let's erase the multiply by 2. I think you guys know what this is. So let's go ahead and take 5 equals 10. 10 equals 15. And 15 equals 20. Alright, so what are we going to do? We're not multiplying, so the only other way to increase the pattern is by adding. And how much do we need to add to get 10? 5 plus what number? Let's say 2. Sorry about that. Still thinking multiplication. 5 plus 5 is 10. So this one works. 10 plus 5, we're sticking with the plus 5 pattern here. 10 plus 5 is 15, so that one works. I think I'm seeing a pattern now. 15 plus 5, that is 20. So it works. So your answer for this is each number in the sequence, we're just simply adding 5. So 20 plus 5 is 25. So that is an addition sequence. Let's talk about a multiplication sequence. Alright, so let's go ahead and talk about multiplication sequence. So here's our sequence, a series of numbers. So 5, 10, 20, 40, 80. 5, 10, 20, 40, 80. What is happening in between the 5 and the 10? Well, you could say add 5. But if you add 5 to 10, you don't get 20. So the add 5 pattern does not work because 10 plus 5 is not 20. That doesn't result in the next number in the pattern. So let's go ahead and erase the plus 5. So we know it's going to be something that we're multiplying. 5 times what number equals 10? 5 times what number? Or you could think your fact family. 10 divided by 5 equals 2. So let's see if times 2 works for this. So go ahead, circle that. 5 times 2 is 10. Is that true? Correct, that's true. 10 times 2 is 20, so that is also correct. Starting to see a pattern here. 20 times 2 is 40, so yes, that is also correct. So in order to find the next number in your pattern, you're simply multiplying by 2. 80 times 2 is going to be 160. Make sense? Alright, so let's go ahead and talk about another sequence. Let's see if you guys can do this. If you want to pause it, pause the video, you can go ahead and try it yourself. But basically what's happening in each number in the sequence, we're multiplying by 3. 1 times 3 is 3. Good. 3 times 3 is 9. Good. 9 times 3 is 27. Good. If you have to, come to a number and you're like, I don't know, 27 times 3. So you'll memorize this eventually, but just go ahead and multiply it out by the side. 7 times 3 is 21, carry the 2. 3 times 2 is 6, 7, 8. So the next number in the sequence is 81. Okay, so if you, the more you learn about numbers, the more you learn about math, you'll see that there are a lot of different little patterns, and like we just explored 2 patterns, a multiplying pattern and a adding pattern. But there's tons of little patterns, and you'll pick these up and as you go along through math. So think of a whole number, double that number. Is the answer to that number even or odd? So let's try this. Here's a whole number, 5. Multiply by 2, because that's what double means, multiply by 2. The answer is going to be 10. That number's even. I'll put an E for even. Let's think of another whole number. Let's try 3. 3 times 2 is 6. That's an even number. Let's try 4. 4 times 2 is 8. That's an even number. So that's the pattern. If the first number is a whole number and we multiply it by 2 or double it, no matter what, you're going to get an even number. So that's your pattern. Alright, so let's talk about scales. Here's a thermometer. I like to think of last lesson we talked about a number line and how that was could be considered an x-axis. A thermometer, since it's going up and down, I like to think of that as a y-axis. So when we're graphing, that'll make more sense. But here is a thermometer, and the smaller numbers are at the bottom, and as we move up, we have larger numbers. And the thermometer measures what? Heat, or lack thereof. So we're going to start on Celsius, and there's 2 different scales for measuring heat that are commonly used: Celsius and Fahrenheit. C is for Celsius, F for Fahrenheit. At 32 degrees Fahrenheit, that is freezing, or 0 degrees Celsius. So that's when water or liquid can freeze. At 33 degrees Fahrenheit, you're not going to freeze. I used to direct traffic, and I would never wear gloves, and I could tell when it was freezing because my hands would hurt so bad after directing traffic when I was in college that my hands would just turn bright red. But if it was 33 degrees, I was fine. I mean, I still felt cold, but it wasn't like unbearable. But if it was 32 degrees, my hands just turned red. And the colder it got, if it was let's say 17 degrees Fahrenheit, my hands just got colder even that much faster and froze that much faster. At 33 degrees, I could go as long as I wanted, and I was fine. So I kind of experienced that firsthand. And then your body temperature, your natural core temperature, is supposed to be 98 degrees Fahrenheit or 37 degrees Celsius. And then 100 degrees Celsius, or 100 degrees Celsius, that's when water boils. Okay, so Celsius is kind of based on freezing point and boiling point of water. Okay, so let's talk about this thermometer here. It's in degrees Celsius, so 0 degrees Celsius, that's freezing. And as we go up, it's getting warmer. Sometimes, if you were to look at a thermometer and you had it fill up to there, okay? There's not always a number where the mercury rises to. So if the mercury rises to right there and it's in between 0 and 10, it's halfway there. So we're going to guess, okay, so if this, we're going to assume that this is exactly halfway in between 0 and 10. So 10 divided by 2, or half of 10, because this is half, is going to be 5 degrees Celsius. Okay? And if we had the mercury, the heat rise a little bit more, all the way to there, now the mercury is in between 20 and 10. What's a number exactly in between 20 and 10? You can't just divide 20 by 2. 20 divided by 2 would be 10. And we know this is large, the mercury goes up past 10. So basically what we're asking is, what's halfway in between these two numbers? So a good little algorithm that I like to use for scales is you take 20 minus 10. The two, if your scale goes in between the two numbers, you take those two numbers, you take 20, subtract 10. Okay, you do that first, and then you divide by however many hash marks there are. And we know that there's two hash marks because we had the one here and one here. Okay, so there's two sections that are in between those two numbers. Okay, 20 minus 10 is 10. 10 divided by 2 is going to be 5. So you're going to go up 5 from there, which would be 15. So this is 15 degrees Celsius. Alright, I'm not very good at drawing thermometers, so I just did a number line up there, little y-axis. So if you had a thermometer and it came up, mercury came up to there. Now notice these hash marks, we go from 0 to 10. These hash marks are not cut, it's not exactly in half. There's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 different sections. Okay, so if we want to know, okay, we went from 0 to 10, how much is that? So let's do the little algorithm that I showed you a second ago. We're going to take 10 minus 0, and that's going to be 10. Okay, that's the first step. The next step is you divide by the number of sections. So we're going to divide by 5. Okay? To know how our scale value. So 10 divided by 5 is going to be 2. So now we know that we're going up by 2. So each hash mark, each set of hash marks is 2 more. So this is 2 degrees, let's say Fahrenheit. We'll do Fahrenheit this time. So this right there is 2 degrees Fahrenheit. But say we went up to here. The mercury rose to that level. Okay, so now we know that our scale is 2. So we're going to go 2, 4, 6, 8, 10. 10 plus 2 is 12. So we know that this is 12 degrees Fahrenheit. Okay, so this little algorithm is a good algorithm to use if you're trying to determine what the scale value is. And in this case, we're going by 2. So hopefully that